Hey everyone, welcome back. In this lesson, we're going to be talking about the rock cycle. So this is a follow-up to our lesson on the hydrologic cycle. They're not necessarily related directly, but all of these different cycles do kind of tie in with one another, and you can see in nature all of these different cycles at play at the same time. So we're focusing on a couple of them. We've already talked about the water cycle, and today we're going to be discussing the rock cycle. So in the last lesson, when we talked about the water cycle, we discussed how water goes from being, let's say, in the ocean up to being in the clouds, and then back on the land surface and maybe in the subsurface. So we talked a lot about the different processes that get water from one place to another. With the rock cycle, our approach will be a little bit different. We will begin by talking about uh, the different types of rocks themselves, the three main categories of rocks, and how they form. And then based on that knowledge, we'll build up an understanding of how to go from one rock type to another. And of course, we have a special guest with us in this lesson who some of you may recognize and who you might see again in this unit, perhaps. Maybe. Who knows? So, before we get into a discussion about the surface of Earth and the rocks that are found there, we need to think about the structure of Earth beneath the surface. So we talked about the different layers of the planet before. We've talked about how the different layers are made up of different stuff. So the core is made out of different stuff than the mantle, which is made up of different stuff from the crust. Um, and this is important because of one of the types of rocks actually comes from, let me see if I can draw this because I've got a new uh, mouse here, so my drawing skills are not necessarily going to be as good. But so from this layer, the mantle, we will have some rocks that originate from this material. So, and this, the layers of the earth are important to the discussion about the rock cycle because when rocks get recycled, um, they dip down from the crust into the mantle, and then sometimes you'll have rocks form within the mantle itself. So the mantle, this layer that I've pointed at with the yellow arrow, um, is also important to our discussion about the rock cycle. We won't be focusing on it too much, but just keep in mind that this discussion goes deeper than just the crust of the Earth. And of course, we talked about the hydrologic cycle in the last lesson. Um, Now we can see from this diagram and from what we talked about in the last lesson that there is a connection between the water cycle and the rock cycle in that sometimes we have water uh, interacting with this subsurface with the material on the surface. So sometimes that can be water in the subsurface or just water on the surface itself, right? You could have the processes of erosion, weathering and erosion can happen due to the movement of water across the surface. So the our discussion about the hydrologic cycle, while we won't be talking about it for most of this, it does have a connection to our discussion about the rock cycle. So there are a few different components of the rock cycle. The rock in the background we will not be discussing as a component, but the three different rock types are what we will be discussing. So that's these three guys over here: igneous, sedimentary, and metamorphic rocks. You guys have probably all heard of those before. And then in terms of additional components, we'll also discuss sediments and magma, and we'll see how all of these different components and rock types tie in together towards the end of the lesson. So we'll begin by talking about these rock types, and then once we have a firm understanding of that, we'll build up an understanding of the complete rock cycle. But the first thing we need to talk about is what is a rock? It's hard to talk about rock types if we don't know what a rock itself actually is. So there's a kind of complicated, not really that complicated, but there's a specific geologic definition for what a rock is. A simple, slightly simplified version of that is the definition here with these 3 points right in here. So we define a rock as something that is solid, it's naturally occurring, and it's made up of minerals that form crystals. So that's a slightly simplified version, but I think it's reasonably accurate. I mean, I'm not a geologist, so I don't know for sure, but but basically, a rock is something that's naturally occurring, solid, and made up of minerals that form crystals. So interestingly, this definition is so broad that it actually includes ice, because ice uh, is a naturally occurring solid, and if you have minerals contained in the water that form that ice, and you have ice crystals, it kind of meets this definition. Um, so it is a very, very broad definition, and that might include lots and lots of things that you didn't know were rocks, or things that maybe don't seem like they should be rocks, or things that don't really behave like rocks. I believe one example of this is, I think it's pyrite, which is classified as a rock by most people who come across the word, um, but it's actually something that drips. It's like a very, very thick liquid, essentially, in that it drips little drops of itself like once a decade or something. So that's something you can look up. I'm not entirely sure that that's completely accurate in terms of the name of the rock, but there's definitely a thing that if you look at it, it looks like a rock, but there's some museum where they've kept a chunk of this object and a container below it, and it drips little drops of itself down into that container over the course of many, many, many years. Um, so maybe something similar that you've heard of would be with uh, glass. Um, but we won't really get into that right now because I don't want to ramble too much before we even get into talking about the rocks. So we can classify different rocks based on their chemical composition. So that's basically what stuff are they made out of, what atoms, what molecules go into making these rocks, and how the rocks formed. So our main focus, because this is a little bit simpler to understand, uh, is going to be the way in which rocks form. Now, of course, you can classify them based on their chemical composition as well, but that's not something we'll really be getting into. We're going to focus more on classifying rocks based on how they formed. So the first type is the igneous rock. So igneous rocks form from, if you read this first point, it says they form from the cooling and the crystallization of magma. So basically, magma is liquid rock. Essentially, it's basically lava, but underground. Um, so as it cools, it solidifies, but as it solidifies, it forms these crystals, and those crystals are what go on to become the overall rock. Um, Now, depending on how quickly or slowly the magma cools, that determines the size of those crystals. So, for example, actually, we'll get to it in the slide, but let's go through these next 2 points first. So, we've got that sometimes magma cools beneath the Earth's surface over a very long period of time. So, this is something that we don't really think about that much, right? You'd think of a volcanic eruption, there's lava flowing on the surface, and then that lava cools and forms a new layer of rock. That is one way in which rocks form. That's this point right here. That's magma on the surface of Earth, which is like lava following an eruption or something. It cools really, really fast, and this forms what we call extrusive igneous rocks. So the difference between these two is that the intrusive, or the ones that form beneath the surface, the intrusive igneous rocks, they take a way longer time to cool down because the magma is a lot hotter. The surrounding environment around that rock is, or around that magma, I guess, is so hot that it takes ages for it to cool down and actually crystallize and form a rock. But an interesting thing about that is that since it takes so long to cool, it gives the crystals time to grow to a reasonable size. So we tend to find that intrusive rocks, the ones that form beneath the Earth's surface and take a really long time to form, um, are what we call coarse grained. And what that means is that those crystals, the chunks that make up the rock, are quite large. Meanwhile, rocks that form by cooling down quickly, when you cool down super quickly, the crystals don't have time to get very big. So we call those fine-grained. And so we find that extrusive rocks tend to be more fine-grained because the crystals don't have that much time to grow as the rock is forming. And so we've got a couple of examples of igneous rocks. We've got granite as an example, and obsidian is an example. These are both examples of igneous rocks. Granite is an intrusive rock, and obsidian is an extrusive rock. You might also see these terms used to describe intrusive and extrusive rocks. You can use them interchangeably, I think, and I might, but just to reduce confusion, I'll try to call them intrusive and extrusive. So here we can see an example of granite and obsidian, granite being the intrusive coarse-grained rock and obsidian being the extrusive fine-grained rock. So you can just pause the video, you can look at these pictures, see what you can notice about the size of the different chunks that make up the granite rock over here, all the different colors and all the different shapes of chunks like this in here, right? We've got chunks like that in there that all kind of amalgamated together to form this larger granite rock. But you can see with all the different colors that there are lots and lots of different pieces that kind of melded together to form this. And we don't really see that in this obsidian rock. So just pause the video, take a minute, look at it, see if you can kind of appreciate that difference in the texture, just in how these rocks look, based on this intrusive versus extrusive kind of thing. So now we move on to discussing sedimentary rocks. So sedimentary rocks form from the accumulation of sediments. So what does that mean? So, well, let's first talk about what sediments are. So in this second point here, we can see sediments are small particles that form from the weathering and erosion of larger formations. So you could have a larger rock formation, so just a big rock. Let's say we've got a big rock like this. And I'm going to try to draw, but forgive me if it takes a couple of tries. I'm still getting used to the new mouse. So let's say we've got some sort of precipitation that comes down, if this is like a hill or a mountain or something. Let's say we have some rain or snow that comes down here, let's say rain, and then it collects on the surface and it starts to flow down the hill. So the water starts to flow down towards the bottom of the hill. Now, on a really, really microscopic level, on a really tiny level, as the water moves along the surface here, it picks up loose chunks of the rock material. So if you had, so if you think of like, if you think of a rock where you cover it with a top layer of sand, then if you poured water on it, it'll carry that sand away as it flows down the side of the rock. So that's kind of what's happening, just on a much slower scale. So it pulls off these tiny, tiny chunks, these like sand grain or smaller sized chunks of the rock, and just loosens them from the rest of the rock surface, and then the movement of the water, or sometimes wind, carries those particles away from the original rock. So what ends up happening is the rock surface up here, I'll draw it in green just with an arrow, that the rock surface up here ends up losing a little bit of material, so the surface might smooth out a little bit as it gets eroded, So it might now look like that. And then at the bottom, we might get an accumulation of new rock material. So we might see that the formation grows down here at the bottom with new rock material in that area. So, or with just a whole bunch of sediments down in here, and then we'll talk about how those sediments turn into sedimentary rocks. So basically, from these two pictures, if I redraw the first one and then draw the second one, so the first one looks kind of like this. So we have our big original rock formation, and then after all of the precipitation and all of the erosion, maybe the top part of it gets kind of smoothed out and is lower in height than the rest of it, but then there's a whole buildup of sediments towards the end. So I've kind of tried to draw that so you can see here that this part of the rock is smoother than it used to be, right? This is also smoother than it used to be, but then this part down here has sort of been extended with this with all the sediments that got deposited at the bottom of the formation. So basically we've got like that the formation grew over here. Or perhaps the particles could get carried away elsewhere by wind and water and just form a different rock elsewhere. But this is kind of the idea that we're talking about. So sediments are those tiny little particles. The weathering and erosion are the processes that carry those particles away from the original rock. And then those particles all gather in the same place due to wind or water patterns. So that's this thing going on here with the sediments collecting at the bottom of that slope. That would be where all the particles gather or accumulate due to the water carrying the sediments and then dropping them off all in the same spot. It doesn't have to be water, it could be wind as well. But these are two of the main driving forces of this weathering and erosion. And then when there are enough sediments all in one place, the sheer weight of this pile of sediments right in here will compress the lowest parts of it that are under the immense weight of the rest of the sediments. So this lowest part in here gets compressed into an actual rock. And so for any of you, the closest example I can kind of give is for any of you that have been in a country where it snows a lot during the winter. So the example I can give for myself is in my hometown here in Canada. The snow, it all comes down in individual snowflakes, right? But as the winter drags on and more snow falls, you'll end up with like a meter's worth of snow all in the same spot. So the snow that's all the way at the bottom of that, the snow that's right above the ground, ends up being compressed by the weight of all the snow above it into solid chunks of ice. And so it's basically that same process, but with rock. So instead of snowflakes turning into ice, it's like sand grains turning into a rock. And so this is kind of how sedimentary rocks form. And we can see here that these sedimentary rocks tend to have a very distinctive texture to them in that they often form in layers. And kind of the reason for that is that you need like an original layer of sediments that, hang on, let me try drawing this a little bit better. So let's say we've got an original kind of layer of just a deposit of sediments, and then that compresses this lowest part right in here just by the sheer weight of the rest of it. This lowest part right here gets compressed into a sedimentary rock. So that's this thing that I'm trying to shade in green down here gets compressed into forming a sedimentary rock at one point in time. Now the rest of those sediments might not hang around, they might move around, they might have other material added to them, and these rocks can take a really long time to form. So it could be thousands or millions of years before you get a formation like what we're seeing over here. So that means that the composition of the remaining sediments on top can change over time. Maybe these particles move and new particles come in that might not be made of the same stuff. So when you get your next layer of the rock, it might not be made up of exactly the same stuff. It might not have exactly the same color. It might not have exactly the same texture. And so then you get this layer that looks different from the layer below it. And then that process repeats with the sediments that are left over on top, and then you get a different layer up here. And you end up getting this pattern of different layers that usually form all horizontally, but then depending on other processes that go on, those layers can be tipped over or flipped over or kind of on a slant, on like what we're seeing over here. So yeah, so here are just a couple of examples of what sedimentary rocks look like, and they often have this very distinctive layered texture to them. So here are a couple of examples of sedimentary rocks. We're not going to talk too much about them just because the pictures are just here for you to get a feel for how these might look different from the igneous rocks that we saw before. So two examples of sedimentary rocks are sandstone and coal. Now coal is interesting because it's organic. It comes from stuff that was alive, right? Which isn't necessarily the case for most rocks. But you can see from this picture of the sandstone especially, you can see that this texture isn't really the same as what we saw with the igneous rocks. It's not got the super coarse grained texture of the granite, but it's also not really super smooth like the obsidian. It looks like it's an amalgamation of a whole bunch of tiny little particles all kind of compressed together throughout the entire rock, and that kind of lines up with what we've been talking about how sedimentary rocks form. And so here's just an interesting example based on the things that we've talked about so far. The Great Pyramid in Egypt, just outside of Cairo, is made of limestone and granite. So this is just a little fun fact to tie in the two rock types that we've discussed so far, because limestone is sedimentary and granite is an igneous rock. So here we can see the two different rock types that have been used together to build this enormous and rather impressive structure. And of course, Dwayne Johnson approves. Now, the last rock type that we're going to be talking about is metamorphic rocks. So metamorphic rocks form from a pre-existing rock that then gets transformed into a new kind of rock that has different physical characteristics or different chemical characteristics or both. So in other words, that means that through lots of heat and lots of pressure, the rocks can change at like a molecular level. So the compounds that actually make up the rock can change through this heat and pressure, and different physical characteristics basically means that they look different. So you might get that just it's not like you take a rock, you heat it up, and it looks exactly the same. If you subject a rock to tremendous heat and pressure, it might undergo chemical changes, and it might also undergo physical changes, which means that the end product will end up having different stuff making it up, and it'll also look different. So an important and kind of interesting fact about that pre-existing rock, which is called a protolith, is that the pre-existing rock can be any of the three types. So it could be igneous, it could be sedimentary, it could be a different type of metamorphic rock. So that means if it was already a metamorphic rock, that means it's already gone through this heat and pressure before. And then if you subject it to even more heat and pressure and you turn it into something else, then you get a different type of metamorphic rock out of it. So the original rock, that protolith, can be any of these three types. It could be igneous, it could be sedimentary, it could be metamorphic. And just a little fun fact here at the bottom for any of you that are interested, there's a geophysicist that has classified Dwayne Johnson, this guy right here, as a metamorphic rock. So that's just a little fun fact for you guys. So here are a couple of examples of metamorphic rocks. Now we can see a similar layered pattern to this one over here. So you can't always just stare at a small chunk of the rock and it's like, oh, yep, layers, sedimentary. Not necessarily. It's got these different patterns can look similar between different rock types, but there are certainly ways to tell them apart. But yeah, here are a couple of examples of different types of metamorphic rocks. So now we're in a position where we can recap these different components. So back at the beginning of the lesson, I said that we'll talk about the different rock types and the other components of the rock cycle. So basically what we have is, I'm going to try drawing this out and then we'll look at some diagrams as well. So, oops. Actually, you know what? Maybe it won't be. Yeah, maybe. Well, okay. I'll try and just kind of draw a bunch of arrows between these words here. So, igneous rocks form from the cooling of magma. So this is how magma is connected to the rock types in this top list of three, and the sediments are connected to the different rock types in the fact that they are what form sedimentary rocks. So this is how these two components down here are connected to the components up here. And of course, metamorphic rocks are connected to igneous and sedimentary rocks in that igneous and sedimentary rocks can turn into metamorphic rocks if you subject them to enough heat and pressure. And of course, a metamorphic rock could turn into a different metamorphic rock. So some rock cycle diagrams will have this kind of an arrow that points from metamorphic back to itself to show you, to kind of show you what's going on there. And so now let's take a look at a few diagrams. Now, before we get to the diagrams, we need to talk a little bit about the words that you're going to see on the diagram. So you'll see, for example, you'll see an I for igneous. I'm just writing the I. Some of them have words, some of them have pictures, and an S for sedimentary, and maybe a small script S for sediments. So you might have an arrow pointing from sediments to sedimentary rocks, and it might say weathering, erosion, and deposition. So this basically means that process of loosening the tiny chunks of the rock. So that's kind of the weathering part. The erosion part is carrying those particles away, and then the deposition is dropping them off at some different location. Compaction and cementation, we didn't really talk about this, but this is that process of the weight of the pile of sediments compressing the lowest layers into a sedimentary rock. This is where we were talking about the ice thing. So that's this compaction stuff. Heat and pressure, that's related to metamorphic rocks. Cooling and crystallization, that's related to igneous rocks. That's how igneous rocks form, if you remember back from the beginning. And melting is basically when any of these rocks turn back into magma. So now that we've hopefully understood all of these different words, the different rock types, the other components that are involved, and all of these processes, we can see some diagrams. So I've got a few different diagrams here just to highlight some different points. So what we can see here is that they've written in the different rock types. So let me put boxes around the different rock types just so we can maybe see it a little bit more clearly. So we've got metamorphic rocks down here, just because they've written everything in all caps and stuff, so maybe it's just a little bit busy. So we'll put a box around sedimentary as well, and we'll put a box around igneous over here. So basically what we get here is that all the red arrows on this diagram are talking about some sort of melting, and implied, they haven't written it in here, but implied in that melting is that if you have a rock that melts and then it cools and crystallizes, it'll form an igneous rock. So in this way you can see that a sedimentary rock, let me grab my red here, you can see that a sedimentary rock can become an igneous rock because if it melts and then it cools and crystallizes, well, something that's cooled and crystallized, that's an igneous rock. If an igneous rock melts and then cools and crystallizes, well, that's just going to be a different igneous rock. And then a metamorphic rock, if it melts and then cools and crystallizes, that'll also be an igneous rock. So in this way you can see that any of the three rock types can become an igneous rock. Similarly, for sedimentary rocks, all the green arrows are pointing towards weathering and erosion and that sort of thing. So if you take an igneous rock and then you, over a long period of time, the wind and the water knock off little particles from the igneous rock, and then they get carried away elsewhere. So that's the weathering and the erosion part. And then the deposition, the compaction, the cementation, that will turn it into a sedimentary rock. That's how sedimentary rocks form. Similarly, if you take a metamorphic rock and you knock off those little particles using wind or water, then that's the weathering and erosion part, and then they get deposited somewhere else, they get compacted, they get cemented together, and that's how you get a sedimentary rock. And same thing once again, if you take a sedimentary rock, you weather it, you erode it, you deposit those particles somewhere else, and then form a different rock, well, that's going from one sedimentary rock to another. So similarly to what we just saw, for the igneous rock, any type of rock can become a sedimentary rock if you use the right process. And then these purplish arrows down here, looks purple to me, I don't know if some people would call that blue, but I'm going to call it purple. So these purple ones down here are what we were just talking about with the heat and pressure. If you take an igneous rock and you subject it to tremendous heat and pressure, and it forms a different rock, that's going to be metamorphic. Same thing for sedimentary. Tremendous heat and pressure is going to form a metamorphic rock. And if you start with a metamorphic rock and you subject it to heat and pressure, you're going to get another type of metamorphic rock. Now this diagram's a little bit busy with all the words on it. Now to help clean it up for you, I'm going to get rid of everything that I've drawn on this slide, just in case you'd like to look at the original diagram. So here you could pause the video if you'd like to look at this again and hopefully get a better understanding of it than the first time. So here's another way that you can look at the rock cycle. I thought this diagram was interesting. I took all of these from Google Images somewhere, but all of these, all of the components are here. Along with some things that we haven't really talked about. We didn't talk about things like uplift. We didn't really talk about stuff like this here. We didn't really talk about burial as the reason why rocks are subjected to that tremendous heat and pressure. We didn't talk about so basically we didn't talk about absolutely everything here, but I thought this was neat because it separates the different components of the rock cycle by being above the Earth's surface or below the Earth's surface. So everything above this gray line here, all of this is above the Earth's surface or on the surface, and everything here is below the Earth's surface. So you can see that intrusive igneous rocks, the ones that form beneath the surface, they're below that gray line, but the ones that form from like volcanic eruptions, that's above the surface. So that's extrusive, and they're above that gray line. So we don't have to talk about everything here, but these sediments, these live on the surface, but when you form a sedimentary rock, the stuff that actually becomes the sedimentary rock is underneath these sediments. So you could say it's beneath the Earth's surface. And then for metamorphic rocks, generally the only place that you're going to get the heat and pressure to transform one rock into another type is by burying it deep within the Earth's surface towards the mantle. And of course, everything can melt and become magma and then cool again. It's not a perfect diagram because you could maybe draw in a red arrow, or I guess maybe not a red arrow, because they've colored them a little bit weirdly, right? These heat and pressure ones have black arrows, but they don't really talk about the heat and pressure part to these red ones. So the color coding is a little bit confusing. They've got uplift with a black arrow over here, but with blue arrows over here. So they've color coded it a little bit strangely, but it's not my favorite diagram, this one, because they've left out a direct arrow from sedimentary rocks melting and becoming magma. And so they've left out a couple of things like that, and just the color coding is a little bit hard to keep track of what's kind of going on everywhere. The previous diagram did a good job of showing the ways in which each rock type can become a different type of rock, right? We don't really see a direct link between, for example, between metamorphic rocks and becoming sedimentary rocks. You kind of have to go this roundabout way where you start here, then it gets uplifted, and then it turns into sediment, and then that turns into sedimentary rock. So it's a little bit hard to follow that that's how you get from a metamorphic rock to a sedimentary rock, but I thought it was clever that they put these different things, they arrange them in such a way that you can see what happens above the Earth's surface and what happens below. So this one is not color-coded, but it does a good job of showing how the different rock types turn into the other rock types. So if we use the same color scheme that we had before, anything that involved melting had a red arrow, right? 2 diagrams ago. So that means that going from metamorphic to igneous, this would be a red arrow. Maybe I'll just put the red just kind of inside the arrow. So melting, that's this one, would be a red arrow. This one is also melting. This would also be a red arrow. Anything that was weathering, uplift, erosion, all of that stuff, that was a green arrow. So we got that here. And then we got uplift over here as well. And then heat and pressure, that was with purple arrows 2 slides ago. So we could have heat and pressure, purple here, and purple here. And the one thing that this diagram is kind of missing is that you can go from a metamorphic rock to a different type of metamorphic rock with heat and pressure. And what the other diagram also showed, but we didn't really talk about, was you can go from an igneous rock to a different igneous rock by just melting the igneous rock. And you can go from a sedimentary rock to a sedimentary rock by weathering and eroding and depositing and cementing those particles. So this is a maybe cleaner description of the rock cycle than what was on the previous slide. It's a little bit simplistic and maybe a little bit to follow without a color scheme, but hopefully this gives you another idea of what the rock cycle can look like. And now the last one. Now keep in mind the structure of this diagram is very similar to what we saw on the previous slide, but heads up, they've swapped around the placement of the rocks. So on the previous slide, we had igneous at the top and sedimentary over here, I think, and metamorphic over there. In this diagram, we've got sedimentary at the top, we've got igneous over here, and we've got metamorphic over here. So just be aware of that when you're comparing the 2 diagrams, the different colors and stuff don't line up because the placements of the rocks have changed. But if you look at the diagram, they've used the same red, green, and purple that we saw a couple of diagrams ago. Anything that involves melting and cooling gets a red arrow. Anything that involves erosion and deposition gets a green arrow. And anything that involves heat and pressure gets a purple arrow. And so this is maybe the culmination, the best diagram we can get of the rock cycle, because you can see that igneous rocks can become igneous rocks with this kind of U-turn red, and we can get metamorphic rocks turning into metamorphic rocks with this U-turn purple over here, and we can get sedimentary rocks into sedimentary rocks with this U-turn green arrow over here. And of course the rest of them, they've all got the words in them, so you can see that metamorphic and igneous rocks can become sedimentary through erosion. Metamorphic and sedimentary rocks can become igneous rocks through the melting and cooling and crystallization, and igneous and sedimentary rocks can turn into metamorphic rocks through heat and pressure. So this is kind of a nice way to tie in everything that we've seen in this lesson. And so that basically wraps this lesson up for us. So our next lesson will be on plate tectonics. That will hopefully be recorded sometime next week, but I've got a whole bunch of exams coming up, so it might not be until a little bit after that. But yeah, hopefully you guys learned something new in this lesson on the rock cycle, and hopefully we can tie in some of this knowledge to our discussion about plate tectonics next time. As always, if you have any questions, let me know in the comments or send me an email or something in the Google Classroom. But if you have no questions, then I will see you all in the next video. Have a good one.